with the next one. So let us get the relation between the SI units and CGS units. Relation between SI units and CGS units for work done. First of all, let us consider the SI units. Let us better to take this. So we know that 1 joule can be written as 1 kg meter square per second square. In CGS system, it is nothing but erg. So where erg is equals to 1 gram centimeter square per second square. So kg can be written in grams as 1 kg equals to 1000 grams. So 1000 grams. Meter square indicates meter into meter. Every meter consists of 100 centimeters. So meter into meter gives 100 centimeter into 100 centimeter. So this is 100 centimeter into 100 centimeter. Okay. So meter into meter, 100 centimeter into 100 centimeter. I convert kg into 1000 grams, every meter into 100 centimeters. Second square as it is. Hence, it will be equal to, let us count on the zeros, children. 1, 2, 3, 4, 5, 6, 7. Totally 10 power 7. This letter is gram. Centimeter into centimeter gives centimeter square upon second square. But we know that the gram centimeter square per second square can also be written as erg. So what is that value, children? Gram centimeter square per second square can also be considered as erg. Hence, the value will be equals to 10 power 7 erg. So what is the relation between joule and erg, children? 1 joule is equals to 10 power 7 ergs. So let me write it once again. So clearly we have 1 joule is equals to 10 power 7 erg. So this is an important relation. Okay, children? Well, so until now, we have discussed something regarding the definitions of work, mathematical expression for work done, as well as the units of work done both in SI and CGS system and the relation between the SI units and CGS system. Okay. So now, let us discuss the types of work done. The types of work done generally are categorized into 3 types, children. One is the positive work, other is negative work, and third one is zero work done. So let us try to define one after the other. First one, all about your positive work done. So when you say that the work done is positive, whenever the direction of applied force and the motion of the body both indicates the same direction. The applied force as motion of the body representing same direction, then we say that positive work is done. But whenever a force is applied in one particular direction and motion of the body is in other direction, in that case, we say that the work done is negative. If either displacement is 0 or the force and displacement are acting perpendicular to each other, in that case we say that the work done will be 0. So let us discuss in detail regarding the 3, one after the other. So first of all, about your positive work done. Let us consider a person, and the person is moving in the towards right side. The person is moving towards right side and he is pulling this load even along with him. So we can see that the movement of the person is in the right side direction. Even the block is also moving in the right side direction. In this case, here no doubt the person applies some force on the body. Some force is applied on the body. Okay. And this force is pulling the body in the forward direction. So this person applying some pulling force on the body and moving it, taking it in the forward direction. So the direction of the force is towards right. The block is also displacing towards right side. So the applied force and the displacement direction of the motion of the body both are in the same direction. So this is an example of positive work done. Okay. Second one, gravity. Let us consider that a ball is dropped from certain height. A ball is dropped from certain height. So clearly the force, why does the ball fall down? Because some force is acting on the ball. What type of force? This force is due to acceleration due to gravity. So gravitational force. So this acceleration due to gravity, that is gravitational force, is pulling the ball towards itself. As a result, the ball travels towards some distance h. So the force due to gravity, let me indicate with Fg, is also acting downwards. The body also moving in the downward direction. Here also both are aligning in the same direction. So this is also an example of your positive work done. So what makes the difference, children? If the direction of applied force and the motion of the body both are in the same direction, then we can conclude that positive work is done. But the same case, whenever a block lying on the ground, is lifted upwards. So a block lying on the ground is being lifted upwards, something like this. If the same block which is lying on the ground is pulled upwards in some direction, upward direction, the force is acting in the upward direction. Okay, the applied force is the force is applied in the upward direction. As a result, the body displaces in the upward direction. The force applied on the body and the displacement caused by the body both in the same direction. In that case, work done is considered as positive. But instead of applied force, if you consider the force due to gravity, we know that always gravitational force will be acting downwards. Gravitational force will be acting downwards. But because of the applied force, the body is dragged or pulled upwards. So if you consider the body, work done by the gravitational force on the body, work done by the gravitational force on the body will be negative. Why? Because the direction of the gravitational force is downwards, whereas the displacement of the body is in the upward direction. Both are acting in the opposite direction. So in that case, the work done is said to be negative. So what is the example, children? Work done by the gravitational force on the body which is pulled upwards is again a negative work done. Not only this, children, the same case if you consider once again, and a body lying here, due to some application of force, the body is displaced through some distance. This applied force will be in this direction and the body is dragged in the forward direction. So in that case, no doubt the work done is positive. But at the same time, as the block is dragged on it, one more force is coming into play, and that is nothing but your frictional force. This is all about your applied force, and we know that the frictional force acts always in the opposite direction. The body is displaced in the towards right side, whereas the frictional force is acting towards left side. So in this case, the work done by the body due to frictional force is again considered as negative. I hope you're getting the... So we are not talking about the applied force in either of the case. We are only talking about the gravitational force, work done by the gravitational force in lifting the body upwards is negative. Work done by the frictional force in dragging the body towards the... dragging the body is always a negative work done. Why I simply called as dragging body? Because whenever the body is dragged towards right side, frictional force will be acting in the towards left side. If the same body is dragged towards left side, the frictional force will be acting on the opposite direction. So frictional force always acts in the opposite direction to the motion of the body. So this is an example of a negative work done. Now let us understand in detail regarding the zero work done. So when does a body is said to be having a zero work done? Whenever displacement is there, how hard you pull the wall, how hard you pull the wall, but you can't ever displace the wall. So the third example is all about, consider a wall, floor, and a person is trying hard, to push the wall towards the other side. But as we know that never the wall can be pushed in front or back. So the wall will not move at all. So in this case, the displacement of the wall is zero. So even though the person applies force on the wall, but the wall is not moving. So the displacement of the wall is zero. In that case, work done is equals to force into displacement. So F into 0 equals to 0. So this is an example of a zero work done. Not only this, children, actually, if you would like to talk about proper definition of work done or proper formula for work done, I told you it is a scalar product. So this multiplication symbol, instead of that, we actually write it as F dot S. This is cross and here it is dot. Okay. So in this case, there is some different formula that depends upon, always dot symbol indicates in vectors F S cos theta. Dot symbol always indicates force and displacement multiplied by the cos of the angle between them. Okay. So this is, you have two different concepts in scalar product and vector product. There you will be learning in detail. Now it's not compulsory. Just remember that whenever a force is acting on a body at some angle, for example, if you consider a inclined plane, let us consider an inclined plane, a body kept on this inclined plane. This body is pulled upwards on the inclined plane by applying some force, or else the body just left for itself on the inclined plane, which is having some angle as theta. The body has a tendency to fall downwards. Okay, and this is the force acting on the body, and it causes, because of the force acting on a body, some displacement is caused inside the body, whether it is moving downwards or upwards, let us not bother. So because of some force acting on the body, it moves a particular distance. The same can be discussed in later case as, let us suppose that the body is somewhere down on the inclined plane of having angle theta. Okay, and by application of some force, let us suppose that the body is displaced through some distance from here to here. So this body initially here, by applying certain force, is being pulled to up the inclined plane. So in this case, the direction of the force is some direction. Horizontally, if you consider that, some displacement is being created. And this displacement can be resolved into some components, and that is a different part. So whenever the force acts on a body at some this angle, something like this. Well, this is better example, children. So let us suppose that the body is lying on the floor and due to some application of force F at some angle to the horizontal. This is the horizontal direction. The force is applied by at some angle F and the block is supposed to be moving to a new position somewhere here. Let us suppose that the block has displaced some distance. So, whenever the force is applied, the block is being pulled in the forward direction and it causes a displacement of some S. So, this force acting at some angle theta for which some displacement S is caused. In that case, the formula for work done is given as the product of F and S cos theta. This displacement along the force direction is taken as S cos theta. So, answer is your Fs cos theta. So, whenever the force acts on a body making an angle theta in the direction of the displacement, that the formula for work done is given as W equals to Fs cos theta. But the same if theta equals to 90 degrees. In this example, if theta equals to 90 degrees, what may happen, children? Cos 90, the value of cos 90 is 0. Okay? The value of cos 90, if theta equals to 90 degrees, then cos theta is equals to cos 90 degrees. This will be 0. Now, work done is equals to F, S into 0. In that case, the work done is equals to F, S cos 90. 0 multiplied by anything will be 0. So, that means whenever the direction of the force applied and the displacement of the body both will be acting each other at 90 degrees, then in that case we can say that the work done is 0. So, whenever the direction of the force applied and the displacement of the body act perpendicular to each other, work done is considered as 0. So, I hope you got the clarity between the positive work done, negative work done and 0 work done, direction of force as well as the direction of motion of the body, both in same direction, they are considered as positive work done. Whereas, the direction of force and the motion of the body opposite direction, in that case work done is taken as negative, direction of force and displacement of the body. Whenever the displacement of the body is 0 or the angle between the force and displacement will be 90 degrees, in that case work done is considered as 0. Not only this, children, suppose if you whirl a ball or swing, something like that, a stone tied to a thread and is being continuously in motion, circular motion, then what happens means in every case centrifugal force is acting on the body towards the center. String is tied to some object over here and by the help of string you are trying to make it on perform a circular motion. So, always the direction of the object will be tangential to that circle, whereas the direction of the force, centrifugal force, is towards the center. So, in that case, the direction of force and the direction of ball both will be perpendicular to each other. So, let me explain the same. Holding the center, an object is tied and this object is moving in a circular motion. Every position the body tries to, direction of the displacement will be in this direction. The direction of the displacement will be the tangent drawn at this circle, whereas the direction of force will be towards the center. Okay, in that case, the angle between the displacement vector as well as the force vector, centrifugal force vector, will be 90 degrees. So, oval shape I gave you to make you understand in a clear way, but the same thing if you consider it in a circular shape, then you can understand better way. So, anywhere the position of the object you consider, direction of its motion, displacement here, and the centrifugal force, direction of the force will be towards the center. Angle between them is always 90 degrees. So, while making a circular motion, then also the work done will be considered as 0. Okay, children. So, with the knowledge we have gained till far, let us try to apply the same while solving a numerical set work done.